Children, if you observe the screen, you can see few news clippings. I have pasted a few news clippings on the screen. What does this say? The first one says 4,700 students visited the science exhibition held in a higher primary school. The second one says 3,500 people were killed, more than 20,000 people were missing, and more than 80,000 people have become homeless as floods hit Karnataka. So these are few news clippings which I just picked randomly. You might be used to reading all this in your daily life. I hope all of you have started the habit of reading newspapers by now. What do we understand by this? Are they the same, that is in numbers as mentioned? See, it's just a news clipping which gives you an approximate value, correct? It's not the exact accurate value that they are pointing at. It could be 4,687 or 4,742 number of students who have participated in that exhibition. It could be less than 4,000 or more than 4,000. Nobody knows exactly as to how many number of people were there. And when we talk about that flood hit areas, we don't even know accurately as to how many number of people were homeless. It could be 76,839 or more than 80,000, that is 84,372. These numbers are also like randomly written. So we don't even know exactly what is the exact number, but we know approximately, very nearer to what the exact number is what is being mentioned there. So in these examples, if we observe, 4,700 or 20,000 or 80,000 are almost the same as the exact number, but not exact number. Correct? They are not accurate numbers as we can take it, but they are nearer to the accurate numbers. These are called as approximated numbers. The approximate number is roughly calculated. This approximate calculation is known as estimation. Children, one more thing I want to stress is approximated numbers or estimated numbers cannot give you accurate answers. They are not accurate numbers. They can be used for immediate calculations or some kind of predictions, some kind of forecasting as such. But when you are calculating or when you have an intention of getting accurate results, estimation process cannot help you with. Let me be very clear that these approximated numbers will not give you accurate answers. They might be nearer to the exact numbers, but not exact numbers. I hope I'm clear with this, children. See, estimation can be done with the results of all fundamental processes such as addition, subtraction, multiplication, and division. Children, you need to notice that estimation becomes easier, or it makes the whole process of these fundamental operations like addition, subtraction, multiplication, and division easier when we estimate and do it. When we estimate, we will be rounding off to a nearer number. It becomes easier and we can calculate faster. These estimated results are pretty much closer to the exact numbers with respect to addition and sometimes with respect to subtraction also. But when we consider multiplication and division, there could be a huge difference between the exact calculations and estimated calculations. Now to start off, estimating the given number to the nearest tens place. We will, here children, if you observe, we will have to concentrate on the place value of the number to which you need to round it off. For example, this number line shows a scale from 50 to 60. If you can observe, it is equally segmented. Okay, assuming that I have two numbers, it is 8 centimeters away from 50, and 52 is just 2 centimeters away from 50. So when I approximate, what you can observe is I have just tried to find the nearest place value or nearest number where I can estimate this particular number, whichever number you are given. If it is 57, I consider this to be nearer to 60. If it is 54, it is towards 50. Now, what do you understand by this now? How to round off a number to the nearest tens place. Now, if the digit at ones place is either 1, 2, 3 or 4, then what do? You replace unit digit by 0. If the digit at ones place is 5, 6, 7, 8 or 9, replace unit digit by 0 and add 1 to the tens place. Okay, with the same rule being followed, we will try to solve an example. Now for example 1, round off 583 to the nearest tens place. Now here, if you observe the digits, what we have is 583. Children, all of you know the place values. So I will just write down, this is units place, tens and hundreds place. Now what is the rule that is given? If the units place has less than 5, that is, if it has 1, 2, 3 or 4, then what do? I replace the unit digits with a 0. So I replace this units place, which is 3, with a 0. Then we don't have any number more than 5, more than 5 or equal to 5. Otherwise, if it had 5, 6, 7, 8 or 9, then I'll have to replace this unit place with 0 and add 1 to the tens place, correct? So I'll have to add 1 to tens place if this was more than 5. Now I have the digit at units place less than 5. So what I do is I just replace this by 0. Units place by 0. Then I just leave tens place unchanged. There is nothing to be done to this tens place digit. And what I get is I have rounded off 583 to the nearest place, nearest tens place, which is 580. Therefore, 583 is rounded off to nearest tens place and it is 580. I hope all of you understood, children. If you observe, we have just tried to change only the units place because it was less than 5. Now for another example, estimate the sum of 2462 and 3487 to nearest tens place. Now the first step would be, children, to round off and then calculate the sum. Now when we round off, 2462 is rounded off to the nearest tens place. See, if you observe, the units place has 2, which is less than 5. So what we do is we just change this to 0. That's all. Now for the second step, the other number 3487 is rounded off to nearest tens place. Now if that is to be rounded off, then we'll have to consider again the units place. And what do we have there? See here, if you observe, 7 is greater than 5. Correct, children? So, as per the rule, if it is greater than 5, then we have 0 at the units place. Then we add 1 to tens place. Correct? So 8 plus 1 becomes 9. Then the other two digits remain the same. So the rounded off number of 3487 becomes 3490. Now we will have to add. Now for estimated sum is equal to, we will have to add. When we add, the answer what we get is 5950. Now, is this very much nearer to the sum if we had actually calculated, not estimating the numbers? Now, we will have to verify that by actual addition. So, 2462 was the actual number, the first number. Then 3487 was the actual second number. Now when we add, what we get is 7 plus 2 is 9, 8 plus 6 is 14, 4 plus 4 plus 1 is 9, then 3 plus 2 is 5. So the actual sum after actual addition gives me 5949. Therefore, estimated sum is nearly equal to actual sum. Moving on. Estimating the given number to the nearest hundreds place. Till now we learnt about rounding off the given number to tens place, nearest tens place. Now it is nearest hundreds place. See, if you observe, we have a digit 368 and this is to be rounded off or estimated to nearest hundreds place. As I mentioned, children, you will have to consider, if it is asked for hundreds place, then you will have to consider the previous one, the immediate previous one, that is the tens place. Tens place has to be considered and then estimated. Now, how to round off a number to nearest 100? It is the same rule, but the place values change. If the digit at tens place is 1, 2, 3 or 4, that is less than 5, replace tens place and units place digits by 0. If the digit at tens place is 5, 6, 7, 8 or 9, that is equal to or greater than 5, then replace tens and unit digits by 0 and add 1 to the hundreds place. I hope all of you got it, children. See here, when we consider the tens place, it is 6, which is greater than 5. If it is greater than 5, we need to apply this rule. What do? I replace tens and units place by 0, that is 0 and 0. Then I add 1 to hundreds place. So I will have to add 1 to this hundreds place, which is 3. So 3 plus 1 is 4. So the estimated number of 368 to the nearest hundreds place gives me 400. I hope all of you understood, children. Now moving on. Round off 5764 to the nearest hundreds place. Here the digit is 5764. In this, we'll have to round off to nearest hundreds place. Hundreds place is this one. So we will have to consider the previous one, immediate previous immediate previous place value that is tens place. So here if you observe, tens place is greater than 5. So what do? I replace both units and tens places with 0. Did you understand, children? Then since it is greater than 5, I add 1 to hundreds place. So finally what do I get is I have rounded off to nearest hundreds place. The actual number was 5764. So when I add one number to this hundreds place, I get 5800. 5800 is the rounded off number, which is the actual number is 5764, 5764. It is rounded off to nearest hundreds place to get 5800. I hope all of you understood, children. Now for another problem, estimate the sum of 8743 and 7275, 8743 and 7275 to nearest hundreds place. So for this, the first step, we will round off the 2 digits and then have the addition performed. 8743 is rounded off to nearest hundreds place, which will give me, children, if you observe, the estimation has to be done for hundreds place, but we will be considering the previous digit, which is the tens place. Tens place has less than 5, so we will not be doing anything except having a 0 there. So the rounded off number is 8700. Now for the next step, 7275 is rounded off to nearest tens place. Now moving on to the next problem, estimate the sum of 8743 and 7275 to nearest hundreds place. So for this, the first step would be rounding off the 2 digits which are given, 2 numbers which are given to nearest hundreds place. So the first one would be 8743 is rounded off to nearest hundreds place, and in that case, when it is hundreds place, we'll have to consider the tens place and check out whether it is less than or greater than 5. Now since, as you observe, 4 is less than 5. So as per the rule, I will not be adding anything, but in turn, I'll be replacing both units and tens place with zeros. So the number would be 8700. Now for the next step, the next digit 7275, when it is rounded off to nearest hundreds place, then what I get is, see, I will have to, though this is less than 5, this is in hundreds place, 2 is in hundreds place. We have to consider tens place when we are talking about rounding it off to hundreds place. So 7 is greater than 5. So what I do is, I replace both tens and units place with 0 and add 1 to hundreds place. So with that, I get 7300 as the second digit, second number, and 8700 as the first number. Now if we add the sum, what I get is 16,000 is the sum. This is estimated sum. Now for the verification. To verify, I'll have to verify by actual addition. So actual addition in the sense I'll take the original numbers 8743 plus 7275. I get 8, 11, 10. So the answer is 16,018. So here if you observe 16,018 is very much nearer to 16,000. I hope all of you understood, children. Now moving on. Children, as we have calculated, we have tried to find out the sum of two numbers after estimation being done. Verbal problems also can be solved in the similar manner. For example, the owner of the theatre decided to sell tickets for a theatre performance. The theatre has 198 rows of 88 seats in each row. Estimate the tickets that can be sold for each show. Now the numbers what we have got, we need to estimate it to the highest value and then calculate. Now 198 is rounded off to nearest hundreds place as what do we get, children? See, when we are doing it for hundreds place, we will have to consider tens place. Tens place is 9. So 9 is greater than 5. Hence the rounded off number will be 200. And the next number is 88. It is to be rounded off to nearest tens place. Since it is to be rounded off to tens place, we'll have to consider units place here, which is more than 5. So the rounded off number would be 90. Estimated tickets needed for each show is equal to, we'll have to multiply, so 200 into 90. Children, as I said, the simplest way could be 9 2s are 18 and have 3 zeros written next to it. The answer is 18,000. Now, when we verification by actual multiplication, what do we get is, first we start with the first digit, 8 8s are 64, 8 9s are 72, plus 6, 78, 8 1s are 8, plus 7 is 15. Then for the tens place value, 8 8s are 64 again, 8 9s are 72, plus 6 is 78, 8 1s are 8, plus 7 is 15. Now adding 4, 12, 14, 7 and 1. So it is 17,424. So the estimated product is a bit greater than the actual product, but very much nearer to it. Now moving on to the next problem. 8 chocolate packets contain 768 chocolates. Estimate the number of chocolates in each packet. Now 768 chocolates is rounded off to nearest hundreds place, as it is hundreds place, so we'll have to consider tens place, which is more than 5. So we replace tens and units place with 0 and add 1 to hundreds place, which becomes 8, 800. Then number of chocolate packets is 8. So the estimated number of chocolates in each packet becomes 800 divided by 8, which gives us 100. I hope all of you understood, children. Now verification by actual division. How do we do the actual division here? We'll have to divide 768 divided by 8 is what we do. 768 divided by 8, we get, since 7 is less than 8, we take 76 together. 8 9 times is 72. 4 is the remainder. There we bring down 8, so 48. 8 6 is 48. So here quotient is 96, which is very much nearer to the estimated value, estimated quotient, which is 100. I hope all of you understood, children. One more thing to be noted, children, while estimating the quotients, we need to round off the divisor and dividend to the given place and then to the division. Estimating the given number to the nearest thousands place. If it is thousands place, then how do we carry out? It is the whole procedure is very much similar to what we did till now, be it hundreds place or tens place. If it is thousands place also, the same procedure needs to be carried out. Now we'll just recall as to what we did for hundreds and tens place. How to round off a number nearest to nearest thousands place. If the digit at hundreds place, children remember we are considering hundreds place when we talk about rounding off to thousands place. Okay. Now if the digit at hundreds place is 1, 2, 3 or 4, that is less than 5, replace hundreds, tens and units place digit by 0. If the digit at hundreds place is more than 5, that is 5, 6, 7, 8 or 9. If the hundreds place value is more than 5 or equal to 5, then replace hundreds, tens, units place value to 0. Then add 1 to the thousands place. We'll have to add 1 to thousands place. I hope all of you understood, children. Here 1897 is the digit. We are considering the hundreds place because we are supposed to estimate it to thousands place. So hundreds place value or the digit at the hundreds place is 8, which is greater than 5. Therefore, the rounded off number would be, we are replacing the hundreds, tens and units place digit by 0. And I will add 1 to the thousands place. If I add 1 to thousands place, 1 plus 1 becomes 2. So the rounded off number would be 2000 for 1897. Is it all clear, children? Now for another problem. Estimate the sum of 33,231 and 20,097 by rounding off to nearest thousands place. To start off, we will have to round off the two numbers which are given to nearest thousands place and then have the addition done. 33,231 is rounded off to nearest thousands place as, children observe that it is thousands place that we are talking about, that is 3. For that, we will have to consider the value of hundreds place, which is less than 5. So we will have to replace all hundreds, tens and units place with 0 and let the thousands and 10,000s place remain the same, unchanged. Now for the other number, 20,097 is rounded off to nearest thousands place as. See children, if you observe, when we are considering thousands place, we will have to, when we are talking about rounding off to thousands place, we have to consider hundreds place value. Hundreds place value is 0, which is less than 5. So we will have to replace all hundreds, units, hundreds, tens and units place with 0 and then let the 1,000 and 10,000s place remain unchanged. Now for the estimated sum. For the estimated sum, it is 53,000. Now if I have to verify by actual addition, the two numbers are 33,231 and 20,097. If I add, 7 plus 1 is 8, 9 plus 3 is 12, 1 plus 2 is 3, 3 and 5. So the final answer is 53,328. If I do the actual addition, I get an estimated sum of 53,000, which is very near to the actual addition. Now moving on. Till now we learnt about the addition process that happens with estimation of numbers. Now we shall try with difference, that is subtraction being performed on numbers after estimation being done. Estimate the difference of 45,630 and 32,148 to nearest thousands place. As usual, we'll have to round off the numbers and then have the subtraction done. First number, 45,630 is rounded off to thousands place, nearest thousands place. Then children, it is 5,000 is the thousands place, but we'll have to consider hundreds place value when we are rounding off to thousands place. So 6 is greater than 5, hence the rounded off number what we get is, replacing all hundreds, tens and units place with 0 and adding 1 to the thousands place, what we get is 46,000. Then for the next number, 32,148, 1 being in hundreds place, we'll have to consider that 1 is less than 5. So the rounded off number would be 32,000. So if we have to find the difference, 46,000 minus 32,000, 6 minus 2 is 4, 4 minus 3 is 1. Now, if I have to verify whether am I really nearer to the numbers, I can do the verification by actual subtraction. Here 10 minus 8 is 2. 12 minus 4 is 8. 5 minus 1 is 4. 5 minus 2 is 3. 4 minus 3 is 1. With actual subtraction, what we get is 13,482. estimate the product of 2645 and 18 by rounding off to its highest place. Children, they have not specifically told you, to what place you need to round it off, but they have asked you to round it off to its highest place. We have two numbers involved in this problem. The first number has 4 digits and the second number has 2 digits in it. So with this, we'll try to round off the first digit. 2645 rounded off to its thousands place, because that is the maximum place value here, to its thousands place value. It can be written as, because we'll have to consider hundreds place value, because we are supposed to round it off to thousands place. So there we get 3000. Then 18, when it is rounded off to tens place, that is the highest here, we'll have to consider the unit place value, that is more than 5. So it gets rounded off to 20. So ultimately the estimated product what we get is, children, the easiest way, as I said, 3 2s are 6 and have all zeros written. That gives you 60,000. If you have to verify by actual multiplication, then you'll have to 2645 into 18 gives you 8 5s are 40, 8 4s are 32, plus 4 36, 8 6 are 48, 51, 8 2s are 16, 21. Therefore, for the next digit, 5 4 6 and 2, when we add 6, then 7, then 4, 47,610 is got by actual multiplication. Now estimate the quotient of 7,687 and 43 by rounding off to its highest place. When we round off 7,687, we get 8,000, because it's rounded off to thousands place and hundreds place value to be considered, which is more than 5. Now next number 43 to be rounded off to tens place, then 3 is less than 5, so we just replace it with 0 and keep it as it is. So it is 40. So estimated quotient is 8,000 divided by 40. Which could be also written as 4 ones, 4 2 times. It's a simpler division which we do when they are simple numbers. So the answer is 200. If I have to verify by actual division, then I'll have to divide 43 1 times is 43, because 2 times becomes 86, which is more than what we have here, which is 76. Now the remainder is 6 minus 3 is 3, 7 minus 4 is 3. Now we'll have to bring down 8, then 43 7 times is 301, and 338 minus 301 gives us 37, and when I bring down 7 again, by bringing down 7 it becomes 377. 8 times is 344, 43 8 times is 344, then the remainder is 33. Children, if you observe, 7,687 cannot be divided completely by 43 when we do actual division, because we are left with 33 as remainder. Though the quotient is somehow closer to what we have got by estimation, the estimated quotient and quotient achieved by actual division are quite close to each other, but we cannot consider it to be accurate calculation. As I have told you earlier also, estimation can be used for immediate calculation and not for accurate calculation. Otherwise, in mathematics, if we consider accurate calculations, or if we are looking out for accurate calculations, then estimation cannot give us the result all the time. It could be possible with addition or sometimes with subtraction also, but multiplication and division gives you varied results when we actually calculate and we approximate it. I hope all of you have understood, children. Now, to summarize all that we have learned, there's a simple rule that you can always follow. Whichever place value it could have been, you might be asked to round off to any of the place values, be it units place, be it tens place, hundreds place, or thousands place. If for the required place, this simple rule is, while rounding off a number to the required place, observe the digit to the right of it, and then, if it is less than 5, retain the same digit in the required place to be rounded off and write 0 in the following places. If it is equal to 5 or more than 5, increase the digit in the required place to the next higher digit and write 0 in the following places. I hope all of you understood, children.